Hey A-level physicists, what's the crack? So today we're going to do is figure out which Feynman diagram is correct. Okay, so the first thing I look at is I see a neutron goes in and it's changed into a proton, and I want to figure out in the weak nuclear force which boson is responsible for that interaction. What we're doing is we see that a neutron is going to change into a proton, and I want to figure out what are the other particles involved. So the first thing I want to do is I would look at the charges. So I know the charge of a neutron is 0 and the charge of a proton is +1. And I know the charges have to be balanced on both sides of the equation. So what I would do is I separate my equation, and if I have 0 charge on this side, I need to have 0 charge on this side. So in order to get 0 on this side, clearly I need something negative. So that's why I'm going to add an electron, because I know electrons are negatively charged. Okay, the next thing then is I want to look at the lepton number, because I know they also have to be conserved. A neutron is not a lepton, so that's why the lepton number is 0. A proton is not a lepton, so the lepton number is 0. But an electron is a lepton. It is a real particle, so its lepton number is +1. So if I've got 0 on this charge for lepton number and +1 on this side for lepton number, I need something that's negatively charged for a lepton number. So I need an antiparticle. But it needs to have 0 charge. So the only antiparticle that makes sense would be a neutrino. Okay? And I show it's an antiparticle by putting the line on top of it. Okay, so that's first what I'm looking for. I'm looking for a neutron changing to a proton and giving me an electron and an antineutrino. So clearly it can't be A. Again, I look here. That looks good so far for B, so it might be B. I look here for D. Again, that looks pretty good, so it might be D. And I look here for C, and it can't be C because that's not an electron, that's a positron. So what I need to decide now, is it B or D? Okay. So what I do when I do Feynman diagrams is I think about timestamps. So what I do is I take a timestamp here. I want to see what is the charge of that line. So the only particle I passed through was a neutron, so the charge of a neutron is 0. So the charge of that whole line would be 0. So what that means is anywhere else where I take a timestamp, the charge of that line must be 0. So what I look at is I pass through a proton line. A proton line's got a +1 charge. And what I've passed through here is my exchange particle. In order to get 0, that has to be negatively charged. It has to be -1. And that's what I have here, so that makes sense. So straight away, I know the answer is B. But just to make sure, let's check D out. So if I do D, I do my timestamp across here. The only particle I passed through was the neutron, and the charge of a neutron is 0. So the charge of that line is 0.